Hi guys, Mike here. Welcome to episode 2 of the Endless Runner mini-series. In this episode, we are setting up our character animation. This means we are creating a blend space that transitions from idle animation to a running animation. Then we are creating the character animation blueprint in C++ and a blueprint version of it, setting up our state machine, and setting up the initialize and update animation functions in the character animation blueprint. So before we get started, I want to show you the original version that I started with a long time ago from older Epic tutorial, which created a endless runner, a different kind one with different ramps and corner floors. I decided later that I want to just use lane switching and have straight floor tiles. So I want to use this project as a kind of reference to show you some ways on how things were done in blueprints and how we are going to do this in C++. So this project started as a third-person template, and that's why the third-person animation characters were created. And like I mentioned before in previous episodes, we are doing this from scratch. So we are creating the blend space from scratch, where you can see we have a speed value which changes from 0 to the max value of 375 and transitions from a idle animation to walking to running. I mean, for the endless runner, he's only running, so actually you wouldn't kind of need to do this, but I want to give you a chance to do this on your own to really know, if you haven't done it before, how to set it up. And the same with the character animation blueprint, which uses this blend space, and it has this character animation blueprint has an event graph with a update animation function that is similar to the tick function that you probably are familiar with. It has two variables. It is an air, a boolean, and a float speed value. And in the update animation, it gets the pawn owner, which will be our run character that we create in next episode. Check if it's valid, and then get the movement component, check if it's falling, and sets the is in air boolean, and also gets the velocity and sets the speed based on the vector length. This whole thing here we are going to do in C++, so we're not having any blueprint code in here. All this is done in C++. And then we have the animation graph, which has a state machine that handles jumping and idle and running. So we are setting this up also, and it uses the is in air and speed variables and so on. So this is what I wanted to show you beforehand, and let's get started and open up our project from last time. So now we're going to create the blend space. Let's click in the animation folder, right click, go under animation and choose blend space 1D. And for animation, it is really important to select or use skeletons if you're not really familiar with it. So the mannequin has a skeleton that will be the base for all the blend spaces and the character animation blueprint and so on. So what we will call this is BS for blend space underscore mannequin. Double click and open it up. So what you can see here is that the skeleton is selected, and we open up the horizontal axis and give it a name of speed, what you've seen before. And default value is 100, but we said we will have it with 375, so it runs a little bit faster. Minimum 4, everything works. Now you can see all the animations available. This is basically on the left side, it's supposed when he's idle, and on the far right side, it's supposed that he's running. So let's drag the idle onto the left side. And you can see here it created a blend sample idle at value 0, at speed 0. Let's do the walk, which should be on this second line, and choose the run on the end line. And if you now drag the green button thingy here, you can see how he's transitioning from walking to running and back to idle again. And you can see here the transitions, these different values. So, and the target weight interpolation is 5. Okay, so this is all that we need to do for the blend space. Let's save this, close it, and now it's time for the character animation blueprint. Now that we have our blend space, let's create our C++ class and select show all classes and type instance. Anim instance is the base class for the character blueprint animation. So let's select this and call it run anim instance. Like I mentioned in previous episodes that we are not using the public and private for now, so we are just creating the source files directly in the source endless runner folder. So let's create a class. So Writer has opened with a generated file, and before we go into coding, let's see what we have to do to convert that blueprint to C++. So in here, we need two variables for is in air and speed. And what I want to do is also create two variables in C++ that will save the pawn owner and the movement component. In here, in the animation, it's similar to a tick, so it's really called a lot of times per second, and trying to get the pawn owner, checking if it's valid, and getting the movement component is something that you can do only once and save it into a variable and then use it in your update animation. So this is what we are going to do. We are creating 4 variables. So let's get started coding. Okay, let's start by creating the U properties for the speed and the boolean. If you don't know about U properties, I have a video in another playlist in the Blueprints to C++ playlist. You can have a look there. Everything explained about Q properties, every kind of tag and stuff that is used with it. So let's create one U property and make it visible instance only. So this is a variable that shouldn't be edited in any detail window. It should only be visible in the instance only. That means like when the game is running that you for debug purposes can have a look at it. So we are doing visible instance only, make it blueprint read only in case you're accessing it from blueprints, which we are doing actually later on. So, and let's give it a category of movement, and it's going to be a float speed. The same thing I want to do for the boolean. So the same U property, the same tags and stuff. So just call it bool, b is in air. As you remember maybe from my old videos, for coding standards, boolean start with lowercase b, and then we have the camel case naming convention. So these are the variables that you've seen in blueprints. And now the next 2 variables, like I mentioned, one for the pawn and one for the pawn movement component, which we will get in a special initialize method, which I will show you in a second. So let's forward declare it as a pawn. It's a pointer, call it pawn. And the same thing, forward declare it U pawn movement component and call it movement component. So these are all our 4 variables that we need. Now let's have a look again at that blueprint code. So what we need to find is a update version in C++. And I also want to have initialization code that runs only once and not in the update animation. So we actually need 2 methods. And there are some methods from our parent class. So if you go into UAnim instance, you will see that there are 2 methods, virtual void native. You can see it here. In many cases, what you will see in C++ in base classes, they start with like native and have some like native begin play or native update animation. This is what we really need to implement or override. So we need the initialization animation, and what we also need to do is virtual void native update animation. And this is exactly the update animation, for example, is exactly this event here, only in C++. So now that we have declared it in the header file, we need to implement those two functions, generate implementation. If you see what I'm doing right now, I'm wondering what I'm doing, you can ask in the comments. I kind of like covered all this stuff in the basic tutorial, so maybe if you're not really understanding what I'm doing here, like generating the code and header files, maybe go into that other playlist and have a look at those videos. I'm just overriding a method here and implementing it in the CPP file. That's all what I'm doing here. So let's implement it. Let's see what we have. So going back again, we see, okay, try get pawn owner. This is target is anim instance, so it's from our actual class. Then we check if it's valid. And from that pawn that we get back, we get the movement component. Target is pawn. And then check in the movement component, is it falling? And the return value will be set to is an air. And then from the pawn, we get the velocity and set the speed based on vector length. So let's see how we can do this in C++. And the first thing what we are going to do is if pawn equals null pointer, pawn equals try get pawn owner. That's the same function that was called in blueprints. And if pawn, so it's the same as you can also do, like we can do is valid. If you just say is if pawn, then you're checking if it's null pointer or not. Is valid, if we go into that function, it tests a little bit more if it's pending kill, and it tests if the null pointer is not null. So it's the same like in blueprints, the is valid function. And then we say movement component equals pawn get movement component. So now in our initialize animation function, we got the pawn owner, got the movement component, and now that we got it once, can really work with it and do the logic in the update animation that we've seen. So let's check, or it's always important to check for null pointers. It's better to check it several times than never and then get like null pointer exception and an editor and Unreal crashes and stuff. So that's not really good. So let's check if pawn and movement component are valid or not null pointer. And then we can say is B is an error. So first now we are setting the Boolean, if it's an error not, movement component, like you remember from the blueprint, is falling. And if you're not using Writer and maybe Visual Studio for coding, you might get like squigglies and error because you need to include the game framework pawn movement component header file so that we can actually access the is falling and that the compilation works. Writer in here is really doing this automatically most of the time, so I just want to mention that in case you're wondering why it's maybe not compiling, because if you're working with Visual Studio then and don't even have maybe Visual Assist. I don't know if Visual Assist can do this now, but you just need to import those header files. And this is what happened here automatically. So now that we have the is falling, we can have a check again. So we got the pawn owner, checked it's valid, we got the movement component, and now we checked is falling and set the Boolean variable, and now we need to get the velocity and the vector length and set speed. So maybe you remember from my older videos from blueprints to C++, or just to mention it here again, the way to convert blueprints to C++, you need to figure out which functions to call that you can see here in those nodes. Get velocity is like a function from actor, that's okay. Maybe we get the pawn, which is an actor, and now we get a vector back and see vector length, and this is called from Kismet math library. And if you don't know about the standard fmath library and stuff, this is a good thing to try out to see, okay, get the Kismet math library, find that function and see what it's doing. And this is what I'm going to show you right now, is that let's say you Kismet math library. And you can see it automatically imported that from Kismet math library. And now with : we can find the what was it called? Vector length function. So you usually start vector, and it's sometimes you just have to find the right function. You see that the way it's named in blueprints is not always the name of the function in the Kismet math library and so on. So if you can't really find that function right away, what you can do is go inside, and you can see this is all the pure functions that are defined that you can actually call from blueprints. This is basically when you call this function here, it actually calls one of those functions inside here. And we can just look for vector length, and you can see that's why we didn't find it. The function is called vsize, but the meta tag in the function defines it a display name called vector length. And so vsize is the function actually that we are looking for. So if we go into vsize, this is the function that we're actually looking for. And you would put in like pawn.get velocity. That's what was here. So this is actually fine if you do it like this. But let's see what vsize does in going in there again. So if you're wondering, I'm hitting Control B. That's the rider layout. I think in standard Visual Studio it's F12. So just getting inside, and you can see that the only thing that this function is doing, it has that vector and it calls size. So in these cases, and you can see size squared and all these other functions, when you are converting from blueprints and you see those Kismet math library functions, 90% of the time you really want to use not the Kismet math library, but what it's actually doing here. The only thing, for example, would be like this vector is 0. It has some calculations, so this would be fine to call, but our function here, vsize, is only calling a.size. So an a is the vector. So what we are actually doing inside our CPP is not using this. We just say, okay, speed equals, we remove this, pawn get velocity dot size. That's the same thing that the Kismet math library would have done, but it's a lot cleaner to read, and you save one, even though it's inline, but I find it more clean to use it like this. And in many cases, the math library also, the Kismet math library, let me find something like here. There's a standard F math library that is the C++ newest or the native math library in here, and the Kismet math library that is available or from blueprints just calls these functions. So if you're using C++, it doesn't really make sense to use the Kismet math library call, because you can actually or use the fmath. This is something that I wanted to say. So okay, so we created this function here, and that's actually it. So this is what the whole stuff here is doing. And we are doing it in C++ in the update animation. If we hit Control F9 or Control Shift B in Visual Studio, pilot, it compiled. And now we go back to our editor. So now we need to create the character animation blueprint itself. Right click in the animation folder where you have your blendspace file from last time, go into animation and create animation blueprint. So now you get this dialog, and what you probably would guess would be to say we get the run anim instance, and because we created this and we need to create this from this class. But there is a bug in Unreal, and it's similar to a bug with the user interface with UMG as well, where now we don't select this one, we go just with the default one. We need to select our mannequin, and what we do is reparent it later to our class. Because what you can see here, let me go back to that old project, and we have in a character animation blueprint, we have an event graph and an anim graph. In the anim graph, we need to create our state machine. And the problem with doing it or with creating the animation blueprint based on our class that we created, then the anim graph disappears, that tab. It's not available. So there's a circumvention. We need to just use it from the anim instance, and let us do this right now. So click anim instance, select the skeleton. There's only one in our project. Click OK, and let's call this BP Blueprint Animation Mannequin. Let's open this up, and we can see we have our anim graph, we have our event graph. There's nothing in there, or only the standard stuff, which we can actually delete. And now what we need to do is hit compile, save first, and then go under File, Reparent Blueprint, and then select our run anim instance class. And now we have access to our variables and so on. So what I want to show you is, you can see here there's no variables like you see in the other one where we had the is an air boolean, the speed. But what you can do is type get speed, and you can see we have our speed and get is in air. So we actually have access to our variables from this animation blueprint graph. And what you can also see is that in C++ we defined the U properties with the category movement, and you can see here we have the category, and we can see our speed is in air, the pawn, and the movement component. So this is for debugging purpose later on, but you can see this is the actual run in anim instance class. Okay, let's finish this episode by creating our state machine. So we type in new, add new state machine. We hook this up with this one. We call this state machine Locomotion, for example. Now double click, and what we now need is a state machine that goes from idle run to the different jumping states like jump start, jump loop, and jump end. So let's add a new state. Right click, new state, call it idle run, connect the entry, and then let's get these states first. So the next state would be jump start. The next one would be jump loop, and the other would be jump end. So when we are starting to jump, when we're in the jump loop, and at the end when he's ending the jump, these are different animations. So let's connect these, create a transition, go like this. So, and now we just need to define what happens in those states and in those transitions. So let's go into the idle run. And here, what we have here is, okay, and in here we need our blend space now. So we type in BS mannequin, and you can see blend spaces, blend space player mannequin. We can hook this up. So the result from that goes into the output. And what we need now is the speed. So we just type in get speed. And so the speed that we're changing in the update animation gets hooked into our blend space, which is the output for that animation pose in that state. So this is idle run. In jump start, we have our asset browser here, and we need a result. So we use the third person jump start, drag it in here, and connect it. So this is the animation that we're playing when we're transitioning from idle run to the jump start state. We go into jump loop, then we have this animation for jump loop. Add this in here, jump end. And now we are only needing the transition rules for all of these states. So let's go into double click on this one, and we have that variable is in air. If the character is in air, that's the transition for is in air for the jump start rule. And we can compile, and you can see there are still some issues because 3 more transitions need to be defined for that state machine. Now the transition from jump start to that jump loop. So for this one, we kind of like need the time that is remaining from that animation, from the start animation. When that's finished, that's when it transitions to the looping animation. And so we need time remaining, and we need the ratio for that function. So time remaining jump start, this one here. And we need to check it if it's less than 0.01 and hook this up. So if really not much time is left, then we can enter into the transition to the jump loop animation. And from jump loop to jump end, what we need to do is we have a Boolean here again, say, or let's get is in air, but not is in air. We need the opposite if it's not in air. So we use the not operator and hook that up. Compile it, save. Then we have one last transition, which is from jump end to the idle run again. And we need the time remaining, the ratio function for the jump end animation. And the same thing, we see if it's less than 0.1. And hook that up and like this. So we compile, we hit save, no errors. So now we have set up our state machine, which now has all the transitions defined, all the states defined for running and jumping, and it's hooked up. And we have our blueprint animation done in C++. So this is it for this episode. So in the next episode, we are setting up the run character and create a C++ class for that and get this character running. So thank you for watching. I hope you enjoyed this video. Please like and subscribe, it will really help me. And if you want to get informed when a new episode is coming out, hit the bell. And so I guess I see you next video. Until then.